Retrieval Augmented Generation combines information retrieval with text generation models to improve the quality and accuracy of responses generated by large language models. RAG aims to address the limitations of LLMs, such as outdated training data and the inability to access external knowledge sources. The main idea behind RAG is to supplement the internal representation of information in LLMs with external sources of knowledge. By retrieving relevant facts from an external knowledge base, RAG ensures that LLMs have access to the most current and reliable information. This approach has two main benefits. It improves the accuracy of the generated responses and allows users to verify the claims made by the model. Before deploying the RAG model to production, it is necessary to convert documents into embeddings. This allows us to search for similar or relevant documents during inference. The process involves splitting the documents into smaller chunks, which can be text, tables, audios, images, videos, or a combination of these. Machine learning models are then used to convert these chunks into embeddings, which are numerical representations that capture the meaning and relationships of the content. Finally, the pairs of the original source and its corresponding embedding are stored in a vector database. To convert information into embeddings, we can utilize pre-trained or fine-tuned models. For text data, a popular model is BERT. For image data, the Vision Transformer model is a suitable choice. ViT is a transformer-based model that can extract high-quality features from images and convert them into embeddings. During inference, when a user provides input, we use this input to find similar or relevant items from the vector database or external sources. The input and the output from the external source are fed into a large language model to generate a reliable output. This approach combines the benefits of both retrieval and generation techniques. RAG is a technique that combines data retrieval with text generation to enhance the capabilities of LLMs. It leverages external sources, such as databases or documents, to retrieve relevant information before generating a response. RAG is particularly useful for applications that require LLMs to base their responses on large amounts of context-specific documents. It may take less time in the training phase but longer time in the inference phase because it involves extra steps to retrieving external information. On the other hand, fine-tuning involves training a pre-trained LLM on domain-specific data to adapt it to a specific task. It allows the model to learn from labeled data and specialize in specific domains and tasks, improving its overall effectiveness, accuracy, and versatility. Prompt engineering focuses on manipulating the input prompts to LLMs to achieve desired outputs. It involves carefully crafting the prompts, including specific instructions, keywords, or formatting, to guide the LLM towards generating the desired response. Prompt engineering often involves iterative experimentation and fine-tuning to optimize the generated output for a specific task or use case. When it comes to customizing an LLM application with your organization's data, it is important to note that these patterns are not mutually exclusive. Instead, they can and should be combined to leverage the strengths of each. For example, we can leverage RAG, fine-tuning, and prompt engineering together. Model can be fine-tuned for domain-specific tasks and crafting prompts carefully with external data. RAG allows them to be anchored on precise, up-to-date, and pertinent information retrieved from external sources. By pairing information retrieval with carefully designed system prompts, RAG ensures that LLMs have access to relevant knowledge that they may not have been trained on. This is particularly beneficial in cases involving domain-specific knowledge, such as acronyms, where RAG can significantly improve the accuracy of LLM responses. By grounding the output of the LLM model on external sources, RAG ensures that the responses provided are based on reliable and verified information. This means that when generating responses, RAG can provide references to the specific sources of information it draws upon. This allows human users to verify the information independently, ensuring transparency and accountability. Overall, RAG is an architectural approach that leverages external knowledge sources to improve the relevancy and efficacy of LLM applications. By combining information retrieval with text generation models, RAG enhances the capabilities of LLMs and enables them to provide more accurate and up-to-date responses.